Okay, so to wrap up our trigonometry review, what we have here is we're going to do some right triangle and Pythagorean theorem stuff. Unfortunately, the trig book that we have doesn't have an appendix that deals with this, so I want to make sure that we take a look at it, refamiliarize ourselves, because it turns out that a lot of our trig functions have their basis in right triangle geometry. So let's make sure we remember some stuff from maybe your geometry days or college algebra days and get done with it. Right? So first of all, what makes a triangle a right triangle? Well, what happens is one of the degrees is 90 degrees. Right? That'll usually be indicated by the little square. All right? So we have a triangle, and one of my angles is equal to 90 degrees. All right? So that's what makes us right. So how do we know when you're looking at one? Well, it's see the 90 right triangle, and like what I will try to do is indicate that so you don't think your eyes are fooling you by showing you a little square. All right. Second one is, what is the Pythagorean theorem? Well, you guys famously know it as a squared plus b squared equals c squared, right? That's what it is. And what it basically does is it relates the sides of a right triangle. Very famous. Okay? And so, again, for some right triangle, right, C is your hypotenuse, right? It'll always be the hypotenuse. That's the side that is opposite the right angle. And then A and B are the two other sides, the sides that make up that right angle. Because this is an addition, it doesn't really matter which side is A or B, so don't get too stuck on that. But it's basically a way that we can relate the sides of a right triangle. It's given by that. I'm not going to go through a formal proof, but what interesting about this is the fact that we're talking about the lengths of sides, but the related by their areas. If I would draw an A by A square here, and a B by B and a C by C square there, this A squared square and this B squared square, if we add them together, we would get this C squared. So very interesting two-dimensional square giving us a one-dimensional relationship between sides. And that's basically what the proof is built on. But I'm not going to do that. We're just going to start using it. So let's find the missing sides for the right triangle shown below. Well, in this case, we're given C, and it looks like we're given B. So my Pythagorean theorem is a squared plus b squared equals c squared. And so plugging in what I know, we can start from there. So a squared, oops, that's a plus, 36 equals 64. If we subtract 36 from both sides, we get a squared equals, what's that going to be? 46, 56, 28. Hope I did that right. All right, and so taking a square root, technically speaking, we've introduced a plus minus, right, because of the square root property, but we are talking about a length. All right, so since we're talking about a length, our a is equal to the square root of 28. Of course, all your radicals should be simplified. This is 4 times 7, so we get 2 square roots of 7, and then our units, oops, that's 7. So 2 square roots of 7 inches is what a would equal to for that information that's given. Okay, so solid ground there. For letter B, what we have is a situation where again, we're given the A value and we're given the B value, and what we don't know is C. So using my Pythagorean theorem and plugging in what we know, we have 7 squared plus 9 squared is equal to C squared. So 49 plus 81 is C squared. C squared in this case is basically, I think that's 120, oh, actually 130, right? 130. So we're going to take a square root. So C is plus or minus the square root of 130. We're talking about a length, so we're going to invoke the positive one, and then there's no nice squares in this, right? Because 130 is 13 times 10, which is 13 times 5 times 2. There's no nice square roots in that. All right, and so that basically cuts to the chase there. What I'm going to basically do is C, D, and E. Now that I've kind of talked you through, I'm going to leave it to Canvas, right? So you guys can wrap up C, D, and E through your Canvas discussion, right? What I will do, since I know some people are afraid of them, let's look at the word problem, all right? And let's try to do that one. So in our word problem, what we've got, let me straighten things out here a little bit. Doing a poor job of straightening it out. There we go. All right. So in this case, Maya's building a rectangular garden that is 8 feet wide by 5 feet long. So let's stop there and start drawing some pictures. So we have a rectangular garden, and what we know is that one side is 8 and the other side is 5. So it's 8 feet by 5 feet. So there's our picture of the situation. Let's carry on. She wants to place a chicken wire along the diagonal of her garden. So that would probably be that right there or the other one. It doesn't really matter. So there's our diagonal. All right. And so we want to know is how much chicken wire will she need for her entire garden, right? So basically, right, she needs chicken wire on this side, chicken wire on this side, chicken wire on this side, here, and then there. So far we know she needs 8 and 8 and 5 and 5, but what we also need to do is add that diagonal piece to this. And so this is where the Pythagorean theorem comes in, because you'll notice we do have a right triangle. We're given side A and side B. We're basically looking for that side C. So 5 squared plus 8 squared is C squared. That's 25 plus 64 is C squared. And I believe that's 89. Invoking a square root, we had a plus minus, but we are always positive. So C is the square root of 89. And I believe 89 doesn't simplify anymore, so we're done. So we have 16 plus 10 plus the square root of 89. So what we need is 26 plus the square root of 89. So if we were guesstimating, if I didn't have a graphing calculator around, 89, I know the square root of 81 is 9, and the square root of 100 is 10. So this is probably roughly about 9.5. So 26 and 9.5 make it 10 evenly. So she'll have a little bit extra. So she probably needs roughly about 36 feet of chicken wire, and that'll be overextended, right? Because that's an overestimate because of that square root of 89. But there would be your accurate measurement, and here would probably be a guesstimate, which you can probably buy pretty easily from Home Depot, or whatever the case might be. All right, so hopefully that serves as a good reintroduction into what a right triangle is, how to identify them, and the famous Pythagorean theorem. Again, we'll be using a lot of these in our trig class. All right, so gather that idea down, and since there's not a lot of homework for it, I want to make sure you guys are discussing it. So again, letters C, D, and E are for Canvas discussion purposes. See you guys in Canvas.